Hello everyone, you're welcome to this channel once again. Today we have a peculiar question on hang glider and how to calculate its sink velocity at sea level at a given coefficient of lift. Now, let's read through the following question. Consider a hang glider with the following parameters. The B, 10 meter, that is the span. The wing area S, 12 meters squared. The weight of the glider, 1.2 kilonewton. The coefficient of drag at zero lift, CDO, 0.01. The Oswald factor E, 0.85. The HN, 0.55. The CMO, 0.07. Now, the glider does not possess any control surface and is trained for different flight velocity by shifting the center of gravity. Now, calculate the sink velocity at sea level for the coefficient of lift of 0.5. Now, we have hang glider today. Now, we were given the span of the glider's wing to be 10 meter. The wing area S, 12 meters squared. The weight, 1.2 kilonewton, which is 1200 Newton. We're given the coefficient of drag at zero lift, 0.01. The Oswald factor, 0.85. The HN, 0.55. CMO, 0.07. Don't let us forget coefficient of lift CL, 0.5. At sea level. Don't let us forget from these particular parameters, we can find our aspect ratio to be B square over S. That gives us 10 square over 12. It becomes 8.33. Now, using the fly path diagram schematic, we can deduce that this will be the velocity as this become V sink and this V horizontal. Also, we can deduce that the flight path diagram, as this part indicate the weight force acting down, and this represent the lift, as this part represent the drag. Now, you know that load factor equals lift over weight. From there, we can deduce that weight becomes load over load factor. Now, by using this particular diagram, we can deduce that W squared equals L squared plus D squared. So therefore, Ln squared equals S squared plus D squared. So therefore, our N squared becomes L squared over L squared plus D squared. So N equals the root of S squared over S squared plus D squared. My load factor becomes CL squared over CS squared plus CD squared. Now, first of all, how do we calculate our CD? CD equals CDO plus CS squared over pi E AR. That gives us CD equals, by slotting out all our values, 0.01 plus 0.5 squared over 3.14 times 0.85 times 8.33. That gives us our CD to be 0.021. Now that we have found the coefficient of drag, the next thing is to calculate the load factor. Don't forget, our load factor becomes the root of C S squared over CS squared plus CD squared. That gives us our load factor to be 0.5 over 0.5 squared plus 0.0213 squared to the root. That gives us 0.999, which is approximately 1. So therefore, our load factor equals 1. Now, by deducing the formula from the V-sync, which is V sync equals rho S CD V into infinity raised to power 3 over 2 weights. You can deduce that V sync equals rho S CD all into bracket 2L over rho S CL into 3 over 2. So therefore, our V sync becomes the root of 2 multiplied by the load factor to the 3 multiplied by the weight over rho S into bracket CD over CL to the 3 over 2. So therefore, our V sync becomes the root of 2 into 1, 3 multiplied by 1,200 over 1.225, which is the density of the sea level multiplied by the wing area, 12, all into square root to bracket. The CD calculated 0.0213 over 0.5, quotient of leaf, to the 3 over 2. Our V sync calculated become 0.77 meter per second calculated. Thank you very much for staying tuned.